Hello, and welcome to my Python Locked Ultimate Ironman series. Join me on this journey where I discuss the ideas, hurdles, and solutions encountered while playing an Ultimate Ironman where all my skills have to be trained by code I write in Python. Today we start our journey in the mines of Lumbridge, where we programmed how to start a mining action. Last time, we are just missing everything else. As you can see, if we just keep running the code every time we want to mine some ore, we get a manually intensive loop, no different from if we were just actually playing the game. If we want to automate this, we need to know when any new ore is added into the inventory. The way I decided to implement this was to break the inventory down into 28 unique screenshots. Then I saved a screenshot of a tin ore and an empty inventory slot to act as a reference point. Now I can compare the live screenshots of my inventory against the tin ore in order to basically calculate the number of open inventory slots I have. Now all I have to do to create the mining loop is to check whenever we lose an inventory slot, because that'll tell me we finished mining the ore. The loop will mine until our inventory is completely full, or someone mines the rock out from underneath us. We'll have to work on solving that latter problem in a future episode, but now that our inventory is completely full of ore, we need to go ahead and drop off all our collected tin ore to the floor so that we can get back to mining. I decided to implement inventory management by creating a function where we give it the name of the item we want to drop, and it uses the template we created earlier to search for all the versions of that item in our inventory and then drop them. I decided to go with shift dropping because pressing and holding shift throughout the dropping process seemed a lot easier than right-click dropping each ore. Our first attempt at testing this failed miserably. It only dropped 2 pieces of ore and then tried to go right back into mining, not finding any other tin in my inventory. I believe this happened because I mostly eyeballed the dimensions of each inventory screenshot, and when I reviewed them, they were very inconsistent. I verified this by printing out the values that represent how similar Python thinks the images are to each other. The values were much lower than I expected, and I solved this by taking a screenshot of the whole window and then opening it in a photo editing tool in order to collect the correct dimensions for each screenshot in order to gather a much more uniform result. Upon testing the new screenshots, I could tell that it was working much better, but for some reason it was skipping every other row. This is likely due to variations in the background of the inventory, so all I have to do is drop the expected value of similarity down from 90% to something like 70%, and it should work perfectly. After making those changes, the new bot is now in a position where we could hypothetically let it run forever. Well, as long as someone doesn't mine the rock out from underneath us. This is a good time to talk about expectations. I've never written bots before to play games, so I fully expect this account to get banned, and I would not be surprised if it happens quickly. There are so many little problems I can already see with my program, and it's going to take a lot of iterating in order to get to a place I'd feel comfortable running it for an extended period of time without getting caught. But even if this account does get banned, we can take everything we learn, refactor major aspects of the code that I'm taking for granted, like mouse movement and clicking, and run it back. Make sure you subscribe because next time we're going to tackle dynamically detecting the tin rocks so that we can mine more than one rock and have free access to move the camera, allowing us to potentially run one of those longer tests I was just talking about. Thank you. Have a nice day.